Thanks for joining us for today's event and welcome to the Houston React Developers Group. My name is Tracy. I am one of the co-organizers, along with Fabian, who is also logged in for today's meetup. We are excited to announce that today's presenter is Alex Kondov. Alex is the writer of the ebook Tao of React. It's a book filled with proven rules and guidelines to build better software. For those of you who are interested in purchasing your own copy, hang in there because he will be sharing a promotion code for everyone attending this event today. Also, there will be a follow-up email with a direct promo link that will be active until August 15th. So today, Alex is presenting on React, architecture, and best practices. I'll let Alex introduce himself further once we hand over the controls to him. Now, during the presentation, please feel free to enter in all your questions in the chat, and we'll make sure that Alex gets a chance to answer those at the end. As always, if anyone who is interested in a topic that they would like to see presented, or if you yourself are interested in presenting, please click on the announcement link in the event description, and be sure to subscribe to the Houston React Developers Group YouTube channel as well. So with that, myself and Fabian, we will go ahead and mute and hide our screens and allow Alex to take it away.
So hello everyone, I will just share my presentation right now. Thank you for having me today. Hopefully, yeah, everyone should be able to see my screen by now. Today I want to start with a very quick story. We have to go back all the way to December 2020. At the time, we were 9 months into the into the pandemic, and I was already feeling a bit burnt out, like a lot of other people. I would imagine. I worked at a media company at the time, and since so many people were reading news, trying to make sense of the world and everything that was going on, we had a lot more work than usual. And this, in combination with lockdowns, no travel, and everything that was going on, really wore me out. So when New Year's 2021 came, I decided that my resolution, that my New Year's resolution would be to find some variety in my work. And since I couldn't find it anywhere else in the kind of the outside world, I decided that it would be time to change my technical stack. That was the least that I could do. I had already been writing React and JavaScript for about 5 years, and yeah, it was high time for a change. But I felt that it would have been a great mistake to do this without documenting kind of everything that I've learned so far. I wanted to share the practices that have helped me throughout the years, and just all the lessons that I've learned the hard way. I don't mean knowledge about library syntax in particular or about specific technologies, but more about like the higher level questions about how to structure an application efficiently, how to architect your code base so you can work with it productively, and so it can serve you, and you won't have to kind of go back and refactor and do changes all the time. These are all the little things that I was missing from tutorials, courses, and boot camps. I've always felt that there's so much information about low-level details and about how to do like specific things with a library, but not enough about how to put these things together to build real software. So I wrote a very long blog post with all these principles, and I named it Tao of React, because Tao is like the universal principle in Chinese philosophy, and this article holds all my universal principles for building React applications. So I thought it would be a fitting name. I just wanted to have this piece of content out there, so if someone else found it who had the same problems and questions that I had, it would help them out. So I post this article. I go to an entirely new team. I started working with Go and other technologies, a completely different tech stack, and then my article about React goes viral online. It got a lot of attention on Reddit. Some newsletters published it. Some people shared it on Twitter, and it turned out that a lot of people were interested in learning more about architecture, not just about how to solve low-level problems. So I decided to kind of extend this article, fill it in with more details, more examples, more different rules and principles, and just publish it as an ebook in the end. And now a year and a half later, I'm once again spending a lot of time with React. I'm back working with JavaScript, and I'm helping people out predominantly with architecture and software design. And today I'm actually going to tell you a few of my principles with the hope that they might help you out as well. Before we dive in, it might be polite to kind of say a couple words about myself. So I am currently working as a principal engineer at News UK. This is the corporation that owns magazines and newspapers like The Times and The Sun. I used to play a lot of D&D. A few years ago, I ran a 4-year-long campaign as a dungeon master, but I decided to retire this year finally, so I can spend more time on writing. And yeah, I write a lot. I've published 2 technical ebooks, and I publish like a lot of articles. I try to be active on social media as well. And yeah, before we start, just something else to keep in mind. Take everything that you hear today as an opinion. There are many ways to build software, and the practices that I will show you today have been successful for me in the past, but they may not resonate with some of you. They may be different from the practices that you've applied successfully, and I'll tell you like I'll tell you the reasons why I think in a certain way, but I fully encourage you to question these ideas, and if you choose not to apply them directly, you can still use them as inspiration. In the worst possible case, I guarantee you that following these practices won't hurt your application's design, even if they don't enhance it for the better. So with that said, in no particular order, the first thing that I want to talk about is about splitting your application into modules. So the conventional way to structure a React application is in containers and components. This is also known as the smart and dumb split back in the day, or as container components and presentational components, or in pages and components. You get the idea. This architecture is a very safe choice. You can apply it to most applications, and it's going to work fairly well. I like to compare it to the MVC architecture for backend applications, for those of you who have dabbled in backend development as well. It's generic enough to work in most contexts, and put simply, no one is going to fire you for designing your application in this way. It splits components into logical groups. Containers are usually like the pages or the larger logical section of your application, and components are the smaller elements that only visualize markup, handle some minimal logic, and have, if they have state, it's like they only handle their internal state. Now, there are two main reasons why I don't like this structure. I think that developers tend to give too many responsibilities to containers. And when things start doing too much, they become large and very difficult to manage. And the more, like the larger a component is, the easier it becomes to kind of put bugs in them, and just testing becomes really harder, because you have to mock more things, think about more interactions, and things like that. Also, every um, uh, like when you look at an application's structure, um, it should tell you a story. You know, when you look at the design of an application, you should be able to understand what what its what this application is about, what the domain is, what it's doing, and what different sections, what the different sections in this application in this application are. And any non-trivial application will end up with just a large giant file with containers and components with no particular organization about them, and this is just not that productive to work with. So instead, I think that you should group your applications into modules, where each module is like represents a specific part of your application. Usually, this can be they can be based on like the top level routes and the top level pages inside of your app. And then if you need more control, or if you have some screen or some part of your applications that is very it has a lot of complex functionality in it, you can continue to split that further. And in this way, every module will only hold the functionality which is relevant to it. So you will have one module that will deal with everything related to the dashboard and hold all the components related to the dashboard. Then you have one that deals about details, and like if you have some detail page or something like that, and is going to hold all components and functionality related to it. Everything that, like, imagine that a new developer kind of joins your team and they open the project and they see the structure and they immediately know, okay, like in this folder, I'm probably going to find things related to this part of the app, and it's just much easier to navigate in that regard. Then my second favorite rule is that we should try to put components in folders. So most React components, they're not implemented in a single file. There's usually one for the actual implementation that holds like the function and types and other like the markup. There you have one that holds all the tests. You have one for the styles, one for utility functions, and hooks if needed. And some components have more markup than others. They have more functionality in them. And if we need to split some of the logic into smaller sub-components, the amount of files that you end up is gets even higher. And putting all these components with all their additional files in the same folder quickly becomes messy. As you can see on the left-hand side, this is just a header and a footer with some helper files, but this already goes like above 10 files. If we add a few more, it's going to get even harder to kind of read and navigate. A better way to structure components is by putting them in their own nested files. This way, each one represents like just each component that represents a larger logical unit should be moved in its own folder. And the subcomponents that, for example, in the in the example that we have on the right, the header component has subcomponents that are called for some items in the header and for the logo, and these can be split in their own subdirectory, kind of communicating to other engineers that these components are they are used only by this main component. They're in the scope of this component, they should be considered private, even though we don't have a way to fully encapsulate them and say that they're private, but they shouldn't be kind of imported by other components. They are only used by this one. Something that I have seen, and also the same goes for like hooks and utility functions. They should reside close to the component that uses them. In general, following the principle of co-location is a good it's a good general principle to follow when you're writing React. And also something else that I've seen is that some developers who follow this structure, sometimes they like to kind of implement all of their logic inside of the index file, because it's like the main file of this folder, so it kind of makes sense to put everything in there. I would suggest that you still have a file named after your component, and then just re-export it together with anything else you need to re-export from the index file. Because if you implement, if you have the implementation in the index file directly, if you have multiple components open, you're going to have multiple files called index in your IDE, and this just gets it gets confusing. All right, off to rule number 3, which is about creating a common module. In the first rule, on the first example that I showed you, there was, besides the dashboard and the details, there was a common module. And we're going to have a lot of, we're going to talk about architecture and design today, and these conversations can be vague. We can argue about, like, the benefits of one structure over another, or like low-level details like what library to use or what practice to follow. But there's one thing that is guaranteed in every code base, and this is that you're going to have logic which is going to be used all throughout the application, just repetitive logic that is going to be used everywhere. This mostly consists of components that you want to reuse, like things like buttons, inputs, some containers components, like cards and whatnot. But it can be like utility functions, domain logic, something specific to the business, or custom hooks as well. So you don't want the design of your application to happen by accident. Like, you don't want to end up with multiple repeating implementations of a button, multiple different implementations of an input that kind of look similar visually, but they're not the same because some developer didn't know that you had a common module, or they didn't know that this was already implemented on some other screen, and they kind of decided to implement it as well. Like most times, you're going to end up with very similar, just repetitive logic all throughout your application, and not just about this is not just about components. This is about hooks as well, or domain functionality, or just small utility functions, things like parsing through some string or filtering through some array based on a specific requirement or something like that. You don't want to end up in a situation where you have multiple of these spread around. So just the fact that your common module kind of exists and it is present is a way to communicate to other engineers on your team and tell them, hey, there is this thing here that we keep, repetitive and common functionality, and so you might as well take a look there. Or if you develop something which can be reused, you should, put it in the common module. This is a very good practice to follow in general. I won't go in details about building storybook stories or things like that. Just having a place to put everything inside of your application, and next time someone needs something, maybe they have to build like a screen that has buttons on it, they'll go and check if this already exists in this module. All right, so next rule is about absolute paths. This is maybe one of the more controversial ones. I don't know. I've had a few arguments with people in the past about it. The reason why I like absolute paths is that making things easier to change is one of the maybe the most important goal when we talk about application structure and design, because like this is something that we do all the time. You import something, you reference it based on the exact position in the like in the code base that it currently has. But the problem is that code bases change a lot. Like, we don't tend to write a piece of software and then leave it for like 6 months. Like, things evolve constantly, they change. You may have to kind of redesign a module, you may have to move things around, you may have to kind of move something from one directory to another. And absolute paths help a lot when it comes to this, because this means that you have to change less things. It just, in a maybe more abstract way, it leads to a less tight coupling inside of your code base. And another problem that they solve is that sometimes it's very hard to understand where things are coming from. Like in the example that you can see here, it's clear that you're importing something from another module, but what if you want to reference a hook from the same one? I don't think that like relative paths are necessarily a bad practice, but I think that it just becomes much easier to kind of to see where things are coming from if you write absolute paths. And I won't go into details about how to implement these because it really depends on your kind of on the bundler that you're using and how you build your project. But I'm sure you can find plenty of examples. And if you're using like Webpack or React scripts, there are like a lot of examples about how you can achieve this. Next up, we have to go back to modules again, and like I told you, multiple reasons why we should kind of try to group um, our functionality in logical cohesive logical units, but I didn't say exactly what we should put inside of a module. So like imagine that like if you're building an admin panel, you may have one module about the dashboard that shows things like statistic and charts. An e-commerce application will probably have a module for like product pages and one for like the listing page that you see on the homepage. If you're not sure how to start splitting your application, a good starting point, again, just to re-emphasize on this, is to look at the top level routes of your app and just start splitting them by that. Once you once you decide on the boundaries between them, then you have to think what exactly each module should hold. So um, you shouldn't have a predefined structure that each module should kind of follow to the letter. Um, you don't need to fit all the modules, like they don't have to all follow the same pattern, but having some limitations around how they should be structured helps a lot, because being consistent in your design is generally one of the best things that you can do. If you follow a similar structures in your modules, this makes it even easier for people who like for people to find things. Like if one engineer is working on one module, they have to go to the other. It makes a lot. It would be easier for them to make sense of what is going on. So in general, a module should be shaped around the problem that it is solving. But I found that in most cases, I end up with like this is a very minimal design of what I usually end up with. I have components, some utility functions, hooks, and this folder core, you've probably already seen it on a couple of my examples, and I think it's a good time to emphasize what core means in these examples. I'm a very big fan of the idea that domain logic shouldn't be tightly coupled to UI logic. And I think that in front-end development, like in the backend world, there are practices like hexagonal architecture or clean architecture that are kind of emphasizing the importance of splitting business logic from framework specific logic. And I think that in the front end world, we're a bit guilty of blending the business logic too much with our framework of choice. And it's not necessarily bad, but it doesn't help us when we have to refactor a UI. And refactoring components is something that happens very frequently. If you have to split a component into smaller ones, you have to add new things, and you don't really want your business logic to be affected by UI driven decisions. So whenever possible, I try to extract like the business specific functionality that I'm writing just in a separate folder, and like this can be just some functions, simple functions that are doing some operations, or they can be even classes if I want to write in an object oriented way, depending on what you want to do. But yeah, this is the purpose of this folder. Then this leaves a lot of people with the question, then what should we put in the utilities folder if we're putting the business logic inside of core? So utils, this is like a folder that usually becomes like a catch-all bucket for everything that people don't know where to place. Like if you're not sure where this function should reside in, okay, just put it in utils and import it from there. And like in my mind, utilities should be like a very lean folder that should be like a toolbox. It should only keep functionality which is very application agnostic, and you can literally pick this folder, move it to another application, and it should work properly. It should, like, you shouldn't put types or like business logic inside of it. It should be something that is only about validating some email or doing some regex validation or iterating through, like, filtering some collection or something like that. But yeah, once now that I have kind of outlined the reasoning behind my folder split, maybe I can get back to the module design here. So we have components, utilities, hooks, and core. Now it's, even though we have kind of grouped our application in modules, it's a mistake to put every single hook inside of this module into the top level hooks directory and put every single utility file that is used throughout this module inside of the utils directory. We should combine all the different like all the rules that we spoke about until now to design our module. So inside of components, you will have a folder which will hold like a particular component, like the header. And if this component, and if only this component is using a specific hook, this hook should live inside of the component. Then if this hook has to be used by other components inside of the same module, you should lift it to the hooks directory inside of this module. And then if other modules need to use this the same hook, then you should lift it and put it in the common module. You shouldn't, like, and again, this is an opinion, take it as such, but you shouldn't reference like one module shouldn't reference components and hooks inside of another module directly. It should only reference things unless you have a very good reason for it. It should only reference other functionality which lives in the common module. So the dashboard, like, should only depend on things that are in the common module. Otherwise, you're gonna end up with this very complicated web of circular dependencies, and this just makes things a lot difficult to imagine. Because then, if one engineer is working in this module and they change something, then turns out, okay, 3 more modules just got their tests failing because you touched something and you didn't even know that people were using it, but turns out they do. Okay, so this was about the high level structure, and I think we can dabble in some lower level details as well. So I want to start with talking about deep components, or deep modules, as John Osterhout calls them in his great book called A Philosophy of Software Design. There he outlines this concept of deep and shallow modules. A deep module is a unit that hides a lot of complexity and allows access to it through a very simple interface. So it hides a lot of functionality, a lot of complex logic, but it gives you a very simple interface to use to access this logic. The alternative are shallow modules, or shallow components in the context of React. Shallow components mean that you have a component that exposes too much, like too many details and too many of its internals, and allows you to control them via props, for example. The problem with this is, yes, if you look at the component on the left, it seems like a powerful and very highly configurable component. It gives you a lot of options, but the question is, does it provide enough value to warrant its reuse? Like in this case, if you have to specify every single one of these details again and again, and imagine how many buttons you have inside of your application, how different would that be from implementing the kind of this logic yourself? Of course, it's going to save you some. It's going to save you some code. It's going to save you a few lines. But as a user of this abstraction, you are going to be aware of everything that it is doing. And if this abstraction has to change some of its details, it exposes so much that changing just anything would result in an avalanche of other changes throughout the application. Just all the details that these components and these modules have, they're exposed. Because of that, we should avoid these and try to write deep components instead. Not because shallow components are necessarily an anti-pattern or a bad practice, but they don't bring enough value. Like in some cases, you may want to write a shallow component, but this should be done intentionally because you have a very good reason for that. But shallow components bring extra. It's an extra layer of abstraction that doesn't bring enough value, in my opinion. On the other side, we have an example of a deep component on the right, and again, I have omitted some details here just to save on screen space. But you can see that here we have a component which gives you a smaller interface to work with. You can only provide you only provide the icon, you provide like the handler, and you provide the state in which the component is. So it can be an idle, loading, or error state, and then the component itself manages like what icon to show, what like whether it's disabled, enabled, depending on its state. It's you work with less, and you have much, how to put it, you have a more powerful tool that you can achieve more with less, if this makes sense. Okay, we spoke a lot about how to organize an application structure, about how to put things into modules, how to grow a module, how to organize the module, and everything like that. But low-level details and structure are important as well. And once again, it's important to emphasize the benefits of consistency, because regardless if your application is structured well or structured badly, as long as it's consistent, people will be able to make sense of it. Like even if your design is not ideal, if you follow the same principles, people are going to be able to recognize these patterns. Of course, I have strong opinions about what good design looks like, but I just want to emphasize again on the importance of consistency. And this is how I usually organize my components. So I have the import statements at the top, and depending on the company that you work in, if you work at some big corporation, your files may have to start with like a copyrights message at the top. That's usually the place where you want to put that. But first you have like the import statements, then you have the interface. Some people like to export the interface in a separate file and import it there. I usually like, unless it's a really large one, I would like to have it close by next to the component implementation, because it carries kind of a lot of important information about the props that the component uses. And then I have the component definition, which we'll get back to in a second. And underneath it, we have everything else. These are subcomponents, utility functions, constants, just anything else that you have to write in this file. I usually put it below the component. So when I open a file, I can immediately see the main thing that it exports at the top. And this is one of maybe something that not everyone agrees with. Some people like to have the export default at the bottom of the file. I usually like to do it immediately, and I do it next to the component definition, and I do it at the top. For many years, I exported at the bottom, but I realized that every time I have to open a file, I have to scroll like through I don't know, a couple hundred, 3, 4, even more, depending on what the component is. Scroll to the bottom, see what is exported, and then go to the top to see what it actually does. And I have to do this every time I open a new file. So now I just stick to exporting at the top, and everything left is at the bottom. In like the object-oriented world, this is a practice called keeping public members at the top of the file and private ones at the bottom. And then the actual component definition. So at first, on the top, I will have like all the different hooks that I'm using, or the different setup that I have to do. Usually it's a few lines of hooks. Then I have the body, which is if I have to do something with that data, prepare some variables, have I don't know, do some data parsing or something. Um, yeah. Then I have guard clauses, which I can use to kind of short circuit the rendering process if I do so need. And then I have the main returned statement of the component. I found that it's very important for me to be consistent, to keep just the hooks at the top and not mix them with any other functionality that I have going on in the body of the component, just so I can it is just much easier to kind of split the setup from the operational logic. And also I try to avoid having guard clauses in between, like in between the body. So I try to avoid having a guard clause and then more logic underneath it, because this is I guess more difficult to understand. If I find out that I have to do something like this, it means that I may have to split out an extra component, and I'm doing too much inside of this one. All right, and next up we have, yep, building custom hooks. This is a practice that many, especially more junior engineers, are kind of afraid of. They are more reluctant to create abstractions around the code that they have to write. Usually, like a general rule that I follow, I read it somewhere online a few years ago, and I would love to reference the person who wrote it, but I just can't remember where I read about that. Um, the rule that I follow is that if I have more than 4 or 5 lines of hook set up, I would extract this into a custom hook and use the custom hook instead. And this custom hook would live close to this component, like it would just be in the same file. It won't be like a public one that lives in the module. And this helps me just keep the body of the component much smaller and much easier to understand what exactly it's doing. So instead of having the use state here and all the other setup underneath it, I can just hide that and abstract it away in a custom hook, and I get a much simpler interface to work with. If you can see on the right example, the last line is how you would use that in a new component. Instead of having all the state and the handlers and everything there, you just work with very simple values. So this way your component isn't even aware if it's setting state, if it's using like a memoized handler, or if it's doing something else, or yeah, it's a lot less complexity to think about. And if you are unfamiliar with this code, you go in, you see a very simple interface. So yeah, something that I would encourage you to do is, if you find out, if you see that your kind of hook setup is getting more complex, and this can be about other things as well, like if you're using the React query library to fetch data, and you have to write more like if your query is lengthier, or you have to do something with the data that comes from that query, I think it makes sense to just put that into a custom hook as well. As a general rule, don't shy away from building light abstractions. They're only gonna improve the overall quality of your code base. All right, and last, we've got something that is similar to the previous rule about abstracting reducer details. So reducers are great when you want to manage complex state. But when this complexity starts growing and you have more, maybe more, when your reducer becomes too big, or you have to make more verbose dispatch calls, because every time you have to call the dispatch function, it needs to take in an object. You have to pass multiple things to it. Like every call will probably, like the prettier, will probably split it into multiple lines. It just takes a lot more space, and sooner or later you find yourself implementing your own Redux inside of one of your components. And This becomes an even bigger issue if you have to pass this dispatch function to a child component, and the child component has to be aware that its parent is using the use reducer function, and this, yeah, and it just leads to an unideal design, and it creates a leaky abstraction because the whole component tree becomes coupled to this implementation. I'm very fond of reducers, and every time where I have to manage multiple pieces of state, I try to combine them in a reducer. Or if I have more complex, like if my state management logic is more complex than usual, I would rather do it in a reducer than directly using state. So my rule for hooks is if I have 4 or 5 hooks, I would put them in a custom hook. If I have 4 or 5 pieces of state, I would put them in a reducer. And we can create, again, a light abstraction over that reducer as a custom hook. It's going to contain all the complexity in there, and it's going to re-export functions with the dispatch type already assigned to it. So when you use these functions, you can just supply the value kind of that you need. And again, this is a much, if you look at the bottom of the example that I have shown here, this is a much cleaner and much easier API to work with. You don't have to be familiar with how the reducer works, its details about the specific types, and you save yourself from adding constants or doing potential typos. And yeah, you just work with simple values, simple functions that accept simple values as well. You don't have to pass in the type and the payload, and it's, yeah, overall much easier to work with, in my opinion. And I think this was it. Yeah. So I just want to highlight again, these rules are part of my book, Tao of React, that I published last year. You can find it on the 2 websites that I have mentioned here, and the organizers of the meetup will send you a direct link to the book. You can use the promo code Houston to take 50% off. And this promo code should be case insensitive, I think, but just to make sure that it works, apply it with all caps, so we don't have any trouble with that. And with that, I'm gonna thank you for your time, and I'm gonna pass it back to the organizers.
All right. Thank you so much. That was awesome.
Yeah, that was. Can y'all hear me fine? Make sure that audio came back correct. Can you hear me?
Yes.
Oh man, that was amazing. Like, I'm eager to finish this book now because some of the problems or some of the things that you described are challenges that my team encounters, and it's one of those things where it's good to go in to with some of these challenges, such as the way you broke down core, common, things such as that. It's good to go in with an opinion. Doesn't necessarily have to be, a strong opinion or that you feel, 100% that this is the correct way, no other way. But it's good to go into some of those challenges with an opinion because you at least have something to go off of and, help build, move forward versus where I've kind of seen in the past is, one developer thinks one way, another developer thinks another, or even like myself, like
Yeah,
I'll do it
yeah.
one way and then 6 months later, I'm like, oh, I read something else, or I feel it should maybe be done this other way. And it's just, it causes headaches when it comes to maintaining. But yeah, this is a really cool book or a really cool presentation. I'm excited to finish this book for sure.
Thank you for having me again. Glad that you like the talk.
Okay, looks like we have a couple of questions in the chat.
Yeah, I'll go ahead now. So Max did have a question in your organized component slide. So silly question, but what is the interface below the component, Alex? Have not seen it in any tutorials. Yeah, if you can go talk about it. And to piggyback on top of Max's question, do you have any opinions? You didn't talk too much about typings, but if you had any more opinions on that, or like files, stuff like that.
Yeah, so Max, the interface is something that comes from TypeScript. TypeScript is basically a superset of JavaScript, and it allows you to kind of write JavaScript with static types that get checked on compile time. If you've worked with a statically typed language with Java, like Java or C Sharp, this makes your JavaScript code much similar to that. And it has some benefits because it allows you to outline what data type each variable should have, and it checks on compile time whether these values follow the interface that you have provided for them. So if you have a component and you provide an interface for it, everyone who uses this interface will have to pass in variables, pass in props with the specific types, and this kind of saves you from the chance of some sneaky bug coming inside of your application. And yeah, Fabian, I didn't I intentionally tried not to include a lot of TypeScript in this book because I wanted it to be more focused on React and not get kind of not to go into the TypeScript specifics because there are still people who have strong opinions about it. Personally, I am very fond of TypeScript. I really enjoy working with it, and I think that any larger team and any like larger company, not just large ones, like any application that has to be developed in a team environment would greatly benefit from TypeScript or using like some type system like Flow. But I guess that TypeScript is like the default standard right now because it allows you to put a lot of more details inside of the code, and it means that you have to store a smaller mental module kind of inside of your head. So it's like, besides the fact that it saves you from some gnarly bugs, it's just much easier to work on and in large applications, and it kind of reduces, I guess, the buzz factor to a certain extent, because the more details you have inside of your code, the easier it would be for kind of things for teams to grow, evolve, for people to kind of change places and all that.
Gotcha. So I did have another question by Lee Lacey, and they took the question right out of my mouth. So the question is, any advice on structuring an Ajax call in React? And to piggyback on top of that, was in your book, or if you have any opinions you want to share on just overall API calls. And to me, that's where I have myself that's where it's like the Wild West. Front end development is the Wild West, but that's like where it's really, really wild. And like, obviously you have like use query.
Yeah,
Some
yeah.
people have it in actual class components, but is that something that your book goes over, or maybe you can shed some opinions on that?
Yeah. So my advice would be that whenever possible, you should try to use the React query library when it comes to accessing remote data. It's just a very powerful library, very powerful abstraction on top of the primitives that React provides you with, and it saves you a lot of writing, and it allows you to kind of outline your outline the structure of the response that you expect with types as well, and it gives you capabilities when it comes to like caching, refetching, or sharing this piece of data throughout different components. So it's also, like, in a certain extent, serves as a state management library, even though it's not one. Like, my advice would be just as a default, like, this is what I do. Like, whenever I start a new project, I don't I try not to use libraries like Axios or Fetch or any HTTP clients directly anymore. I just try to rely on React Query. But if for some reason you can't have that, like you can't use that library or any of the others that have a similar API to it, I would suggest that you kind of hide the details around the HTTP call as much as possible. Create. It can be a class, it can be an object, it can be like a module that just exports a couple of functions. Just prepare some functionality that hides the complexity of making the call and lets your components operate and work with a more kind of domain-centric language. So instead of having like an HTTP client directly that does a get call or a post call, have like a function that is called get my articles from somewhere, or update user preferences, or something like this, something that is good, similar to how we abstracted the details about the reducer. Just hide the details that this is actually making an HTTP call, and instead just it's a function that takes some simple value, and it returns a promise. I don't know if this answered the question.
No.
Yeah.
I actually like the advice of starting off with a library such as React Query off the bat. Like don't even worry about
Yeah.
it. Don't because once you reach down and you start messing directly with fetch, then you need to start asking yourself like browser compatibility. And it's like it's good to just kind of abstract that out to a library and let them take
Yeah.
care of it, because at the end of the day, you just need to make an API request. You don't care how it gets there.
Yeah, absolutely.
So if anyone has any more questions, please drop it in the chat. It looks like we kind of be running thin on them, but I did have one question, and it's just overall this architecture, these opinions, do they translate to other front end technologies? Obviously, front end is constantly evolving. I just wanted to know, is this something that do you feel can be applied as we kind of grow as a community, maybe change different to different libraries or frameworks in the future?
Yeah. To be quite honest, I haven't followed closely the development of the other popular front end tools in the last few years. But it's funny that the main inspiration for some of the rules that I have applied to React they've come from backend development. They're not something that I have conceived myself. I've been inspired by other books, other technologies, other practices. I mentioned hexagonal architecture and clean architecture in the talk. So I'm pretty sure then that on an abstract level, if you take each of these ideas and you strip them of the framework specific details, you're going to have a lot of success applying them to other technologies as well. I'd love to give an example, but unfortunately I haven't worked with Angular or Vue in a while, and I don't know how their APIs have evolved in, let's say, the last 2-3 years. But I am kind of taking a look at Svelte right now. I think it looks pretty cool, and maybe in the next few years, if it takes off, I'd be happy to write something like that for it.
Awesome. So John Boy did have a question. Is your book, is it a physical copy or a digital copy? No, obviously digital, but do you happen to have, is there a physical copy that can be purchased? Or is it one of
Uh,
those books that, evolve?
yeah, I only have a digital copy for it, and this is intentional. It's because I want to keep this book up to date as time passes, and I've already updated it 3 or 4 times just to kind of um, so I can visualize how trends change in the React community in general. And I want to keep doing that, and I want to know that once and I want to know that when someone gets this book, they're going to get the latest content. I don't want to publish a second edition in a few years and ask people to get it again just because 10 of the rules inside of it are different. So yeah, I'm like I hope that I have the time to keep doing this in the next few years. It's definitely not easy to kind of change everything and re-export and upload the whole book again and again, but it's
Yeah, but it's
yeah.
okay though, because we're front end developers and we're okay with major breaking changes.
Yeah.
But cool, awesome. Looks like we kind of we're fresh out of questions. Oh, actually, looks like we'll go ahead and we'll go over this one last question. I know obviously we're coming up on time here, but Lee Lacey asks, how in depth does your book go into custom hooks?
It doesn't go much deeper than what I just spoke about. But if this is something that is interesting to you, I'd be happy to help. You can find me on either Twitter, or LinkedIn, or whatever works for you, and I'd be happy to have a chat about custom hooks.
Awesome. Well, thank you so much, Alex. Tracy, I'm going to hand it back off to you if you want to go ahead and close this out.
Yes, thank you again, Alex. It was a pleasure having you for our presentation meetup group. Really appreciate it. And thank you again for sharing our promo code with all of our viewers. It looks like there are people already stating that they are purchasing, so this is awesome. Okay, with that, we are done, and we will see you guys next time, and have a good one.
Thanks,
Thank
y'all.
you for having me.